Example 5 is evaluate the indefinite integral of integral e to the 2x sine of 2x dx. So this is a situation where we have a product situation, and I'm going to have to do some kind of rule to simplify this. U substitution is not going to work, and so in this case I'm going to use integration by parts. You can choose u and dv to be either one. It actually doesn't make a difference in this one. Neither is a great option, and so we'll just have to pick one. So I'm going to pick my sine of 2x to be my u and my e to the 2x dx to be my dv. Again, if you switch those, you would end up doing a very similar process here. So in this case, doesn't matter what you pick. So I'll go ahead and do my side work, get that going. Du is the derivative of sine of 2x. So that'd be cosine of 2x times 2 dx. I'll rewrite that to be 2 cosine of 2x dx. That was a little chain rule. And then my v is the antiderivative of e to the 2x, so that would be copy it. And then my little trick we talked about is divide by the coefficient, which would be 2. So now we can go ahead and substitute. So e to the 2x is out, and that's going to be my e to the 2x dx is going to be dv. And my sine of 2x is out, and u is in. So that's my subbing. I'll apply the rule. The integration by parts rule is the integral of u dv equals u v minus integral v du. So I got my rule, and now I'll unsubstitute. So u is sine of 2x, and v is e to the 2x over 2. So that should be good. Minus integral v is e to the 2x over 2, and du is here, it is 2 cosine of 2x dx. So if I simplify that, I do have a 2 on the top and a 2 on the bottom, but I still have a product situation where I've got e to the 2x times cosine of 2x dx, so I am going to have to do integration by parts again. I'm not able to solve this integral without it. So I'm going to switch colors. I'm going to switch over to purple, and I'm just going to work inside this box. So I've got an integration by parts within the integration by parts. So I'm going to start over. I'll write it all in purple. I'm going to pick a new u. I want to be consistent. So because I picked trig to be my u before, I'm going to pick trig to be my u again. If not, it gets a little messier. So in order to keep it clean, I'm going to try to be consistent and stick with trig being my u and then my exponential function being my dv. So it's e to the 2x dx. I'll do my side work. So du equals the derivative of cosine of 2x, which is negative sine of 2x times 2 dx. And v is antiderivative of e to the 2x, is just copy it. And then the little shortcut is divide by the coefficient of x. So I got that ready to go. Just going to work in my little purple rectangle. So integral e to the 2x dx, this part is dv, and then cosine of 2x is u. That was my subbing. My integration by parts is writing down the formula, so it equals uv minus integral v du, and now I'll unsubstitute. U is cosine of 2x, v is e to the 2x over 2, minus integral v e to the 2x over 2 times du, negative 2, gotta make my box a little bigger, negative 2 sine of 2x dx. All right, so you may notice that when we cancel out the 2's and cancel out the negative, that I still have a product for this integral that I'm stuck with. And if you look close, you can see that I've actually just looped right back down to the beginning, or right back to the beginning. So take a look here. The beginning was integral e to the 2x sine 2x dx, and I have integral e to the 2x sine of 2x dx. So I've actually just kind of made my way all the way around. So I did an integration by parts, did another one, and now this is the same as where I started. So I'm going to pause, and I'm going to try to reevaluate what I could do in this type of situation. I am going to rewrite all of it. So I'm going to take my question, which is here, and I'm going to rewrite it. Integral e to the 2x, sine of 2x, dx. And I'm going to write what I have so far for my answer. I've got this original uv, I've got this uv, and I have this integral. I also have this little minus that I have to distribute there and there. So if I look at what I have in green, I have sine of 2x, e to the 2x over 2. And then if I distribute my minus, I have minus cosine of 2x, e to the 2x over 2. And then if I distribute that minus again, I have minus integral e to the 2x, sine of 2x, dx. So instead of continuing to go around in circles, I'm going to look at what I have, and instead of treating this like, a problem and an answer, I'm going to treat it like an equation, because that's what it is. It's this equals this and this and this. So side note, you don't have to write this down, but if I had x equal like y plus z minus x, if I said combine like terms, be like, okay, I can combine like terms. I've got an x on both sides, so I could add x to both sides. So I'd have 2x equals y plus z. If you have like terms, you can combine them. I'm going to treat this and this like terms, and I'm going to combine them. So because they are the exact same thing, they are like terms, and I can say, well, I would like this on the right to be added over to be combined with its like term on the left. So I'm going to take each side and add integral e to the 2x sine of 2x dx. So I'm not treating it like a question, I'm treating it like a term. When I do that, it cancels out on that side, and over here I've got two of them. 2 integral e to the 2x sine of 2x dx. And then I'll just rewrite this stuff. Sine of 2x, e to the 2x, all over 2, minus cosine of 2x, e to the 2x, all over 2. So that allowed me to stop what I was doing, combine like terms, and now I am looking at, okay, here's the question. I would like to know what the answer is. The only thing standing in my way is this extra 2. How to get rid of an extra 2? Divide both sides by 2. So now I have my question, which was here, and it equals the answer, which is over there. So I'll rewrite it. Integral e to the 2x sine of 2x dx equals this fraction divide by 2. When you divide by 2 and then divide by 2 again, you're actually dividing by 4. You would get there if you did copy dot flip, but that's a little shortcut. Divide by 2 and divide by 2 again is divide by 4. Minus, same situation over here, cosine of 2x, e to the 2x over 4. And then we did an integral, so we have to automatically pop in a plus c at the end for that constant that could be there.